Okay, in this video, I want to start explaining some of that function notation. We saw a little bit of that in the last video, and I want to kind of describe it. So y equals f of x. Okay, this is pronounced f of x. This is not f times x. This is not f times x, it's f of x. X is the input value, okay? So if I write out y equals mx plus b, this can be written as f of x equals mx plus b. Now I have a place to put my input values. So it's like showing what you're putting in for x right there. And so we're kind of letting y become f of x, which probably doesn't seem like it'd be beneficial at all, but give it time as we go further, it will become more clear of why you'd want to do this. So let's do some examples of doing just that. So for this first example, I have a function here, f of x equals x squared plus 3x minus 4. And the first one I want to look at is, what if x equaled 0? Okay, well, if I plug in f equals 0, I have f of 0 equals 0 squared plus 3 times 0 minus 4. Okay, so what I found was f of 0 equals negative 4. Okay. Well, what is that? That's the y-intercept. That's the y-intercept. Okay, and we're going to get into that. I think in chapter 5, we're going to dive right back into that of that y-intercept for this. But for now, we're just plugging in values. What if x equaled 1? F of 1 equals 1 squared plus 3 times 1 minus 4. That's 1 plus 3 minus 4. And that looks like that's 0. That's 0. So that implies that f of 1 equals 0. All right. Well, what is that? That's 1, 0. That's the point 1, 0. That kind of looks like that's the x-intercept. Now, I found it by coincidence that I happened to plug in f equals 1, and I found the x-intercept. Again, we'll get into the f-intercept, or x-intercept, y-intercept later with functions, but they still exist. They still exist. All right, this one's kind of weird, but let's do it. Where we're going to plug in x equals a. How would you do something like that? So f of a would be a squared plus 3a minus 4. Okay, and that's it. That's all you have to do. So it's just kind of like a change of variable situation there. So that's all we had to do. What about this one? X equals a plus h. Let's plug that in and see what happens. So I have f of a plus h equals a plus h squared plus 3a plus h minus 4. Okay. Now I can, of course, start distributing and simplifying, but that is technically plugging in a plus h for those values. All right, I'm going to leave that there for now because we're not going to do anything more, but I wanted to go ahead and show you that. Now, again, we can distribute that and start simplifying, but I just wanted to show you what plugging in a plus h looks like in this video. Now, let's look at what if we're given a graph. We're asked to find what is f of 2. Well, that 2 is the x value. So I'm looking at x equals 2, and then that's going to be right here. And so it looks like y equals 1. So I think that equals 1. Okay. Now, what about this one? F of x equals 2. F of x equals 2 is like saying, okay, it's right here. So I'm looking at y equals 2. Now, what are the x values when y equals 2? I have one right here, and I have one right here. And unfortunately, those aren't, they're not quite perfect. So, I have to kind of guess what's going on here. So I'm going to say that x would equal, let's say, negative 1/2. And for this one, let's say 2.5 or 5/2. We can say 5/2 for that. That's probably roughly right there. Okay. Now in chapter 5, we're gonna dive really deep into that idea and really start diving in of how you can pull that apart. But for right now, that's fine. We're just kind of looking for what would the x value be, what would the y value be for this. All right. So there's something called the domain and the range. In this class, we're going to really focus on the domain, and the range exists. We can talk about it, but let's talk about the domain. So the domain consists of all the input values, the x values. So it's all of the x values that the function can possibly have. Let's go ahead and go back up to this picture since we have this nice graph here. What are the x values? Well, it seems like, it's kind of a reflection on this x equals 1 here. There's a bit of a reflection. And the x values just seem to keep going to the right, right? I mean, as this function is climbing up, it just seems to keep going. There doesn't seem to really, the picture stops, but it doesn't stop itself. And that's true over here. It's going to continue going that way to the left. It's going to continue going to the right. So it's really going from, infinity with the x values and negative infinity here. So it just keeps going. So there is no restriction for the x values. And that might be a little confusing because it's the first time you're looking at it or thinking of a function in that way. But there's no restrictions. So the domain for this picture, the domain is negative infinity to infinity. It doesn't stop. All the x values are part of the domain. So these are the x values. Now what about the y values? That's where the range comes from. The range is the y values. And it does have like a little a stopping point, right? It hits y equals 0 right here, and then it goes up on both sides. On both sides it goes up. So I would say 0, including 0, to infinity on that range, right? We're using that interval notation to describe that. So again, the range is the y values, and the domain is the x values. We're going to really focus on the domain in this class. In the next video, I'm going to talk about how you can find the domain if you're given something in the f of x notation. So please watch the next video, and we can start going over domain.